This is working, right? Okay, great. Yeah, I will try to tell you how to prevent it. Though there are many challenges, as you will see. And maybe it's not always citizen science only, it's also experts. So I think we need both. We need to complement the two, but you will hear from that later. Who of you knows the doomsday clock? Oh, wow. More than half know the doomsday clock. Okay. So the doomsday clock is not looking very good, unfortunately. So I don't know if you also are familiar with the timeline of the doomsday clock. So, you know, it was the initial setting when they thought, oh, let's try to track how close we are to midnight, preventing disaster and extinguishing humanity, essentially. That's what it's about. And there are different components, but initially it was driven by the nuclear arms race, which started in the 50s. It then went up. There was a time when they nearly blew off the world through nuclear disaster. There was then some kind of insights and diplomacy between the East and West, and that was also why actually our institute in 72 in the end was founded, because of the need for diplomacy and science diplomacy. Then, unfortunately, there was the proliferation of nuclear arms. India started to test nuclear weapons. It went up again. Then it went up and up. So this was the time when, you know, there were lots of discussion. Was my kind of upbringing, school time. We were all afraid. There was this Star Wars thing already during Reagan. And then suddenly Gorbachev, it was Mikhail Gorbachev, by the way, who had the initiative that time, who said, you know, let's talk, let's get to a table and reduce nuclear weapons. And this meant, and it was the initiative of Gorbachev, which brought us down to here. After the 90s, actually, there was a speech by Putin in the German Bundestag asking to join NATO, which was declined. It was at that time when we had no problem. And we were 15 minutes away from midnight. We are now 89 seconds away from midnight. This thing went up. North Korea, Iran, all the rest of it, most of it was related to the risk of nuclear war, essentially. We are now really not far away, 89 seconds, and the reason why it was put to nuclear 89 seconds was because we have the nuclear risk, we have other very important global issues such as climate and biodiversity crisis. We also have a new upcoming risk, which is, as you all know, and we're discussing it, artificial intelligence and the possibility that we might lose control of it. And this is not that it cannot be controlled, it's because if you control it, you also become less competitive. This is the problem. This is the fundamental problem, that you can easily control it if you want, but some they don't want to control it because it's a race between countries, who wins first, who gets artificially moved more quickly, moving towards super intelligence. It's a risk coming, and we have still the biological threats of pandemics and so forth. If you now draw this in some kind of graph where you look at the severity of the impact versus the probability that it would happen, you would probably come up with something around those lines. Asteroid impact would be terrible, but it's very low. It's really low, especially in the next decade. So the risks are for the next decades to come. The AI misalignment, getting out of control, is still kind of not that risky, but who knows where it's moving, right? Nuclear war, for sure, is a really big risk we have, but even more probable, though maybe with a little bit less impact is climate catastrophic risk, and then the pandemic, as well as very, very probable biodiversity and ecosystems collapse. There is a really, really interesting report I would like you to explore. It's extremely interesting. It was written in 24. It's global catastrophic risks and how they can also potentially be managed. There is also a little bit of hope in there. So it's not about all doom and gloom, but also there is some hope. And of course, the younger generation is rebelling, and understandably rebelling, because the risks are real, the risks are there, and we need to acknowledge the risks. And I think we do have a choice, where are we going with respect to global warming, with respect to ecosystems, but also, of course, the nuclear threat. And it's not only that, it's also now, as we know, especially microplastics found in humans, in fish and everywhere, are becoming really another risk which we have to deal with and can be dealt with. The right agreements, the right national policies can do the job, but a lot of developing countries, actually my wife works in that field. She was just in Uganda writing the National Strategy for Waste 2030 for Uganda, and it's really looking bad. There is waste in Uganda currently put into the Lake Victoria because they don't have any space and it's easier. Another one which is maybe not so well known, but it's really, really serious, is the loss of insects and pollinators. In particular, pollinators are so critical for food security, and we can see the reduction of pollinators already having effects on food security in some countries, including China. It's something we have to acknowledge. Coming back to our institute, YASA, which you might heard about, might not, but I think we're well placed. We're currently a bit in a financial crisis because the US has withdrawn lots of money, but we're coming back, I'm sure, because we're globally very well placed. And we are trying to kind of also do policy advice and really tackle those big global challenges. But also, as we were set up for an institute dealing with science diplomacy, I think science diplomacy has a really important role, especially in those days, to play to bring things back. And if you now look at the arm race taking place again and the investments done by Europe and other countries into weapons and rearmament, and how much little money is actually flowing into diplomacy and understanding peace, is actually embarrassingly low. But yes, we have to deal with where we are. The big question now, coming back to citizens and citizen science, is what can citizens' data do to mitigate climate risk? So the real answer, I'm afraid, is actually not so much, but something. So I will go into detail what. But what citizens can do more to prevent catastrophic events, including climate change, in a democracy, in a functioning democracy, they can vote. So there is some power, and this is probably much more important than citizen science data to really make a big difference, especially the right-wing parties are, as we know, taking over, and we need to better understand why and what can be done. So what should we do now? That's the big question. Where should we invest? Maybe we should all found now a new political party or something like that. So it's something to think about, seriously. Anyway, coming back to citizens' data and the amounts of data being generated. So if you look at TikTok and all the rest of social media, there are 1 billion data entries. So not the amount of terabytes, it's about 400 million terabytes of data produced every day globally, 400 million. But if you look at entries and amount of if you count one TikTok entry as one, it's 1 billion a day. TikTok, I think, has about 150 million videos put in by citizens every day. So the user-generated content is tremendous. The citizen science data. So if you look at user-generated data, which is useful actually, because I would classify this other rest not as that useful. It's a very, very small fraction. Maybe it is useful for businesses and others, yes, but not really for science. Then OpenStreetMap, air quality monitoring, community reporting, Ushahidi, citizens observatories, it's 0.3%. And if you then look at citizens actually active data, so there is a lot of passive data which you automatically kind of collect, but it's useful. But if you really look at the very small portion of actively collected data, which is iNaturalist, eBoard, these are actually big ones. They're also used for policy making, for SDG reporting. Zooniverse projects, Freshwater Watch, GeoWiki, by the way, and so forth, then it's a very, very small proportion of that. But as we know, articles in citizen science are actually going up. This is not updated. It's going up a lot. So there is a lot of new data coming. If you look at the breakdown thematically, biodiversity research is still leading in terms of citizen science contributed data, then followed by health. Actually, if you look at changes over time of citations, so these are now citations between these different themes, you find that health is actually now taking over. So there's much more citations now in the health field, an increase of 124% compared to the other fields, which is something interesting, which shows that in the future there will be probably more and more active data being collected in the health field by citizens. Where citizens also can contribute a lot, and where there is a big issue is with respect to SDG reporting. So a lot of countries, especially in developing countries, in the emerging also markets, there is still a big lack of SDG indicators, and there's 92 environmental indicators which still lack data. And this is really something very worrying, that we cannot even understand where are we currently with respect to being on track towards addressing the SDGs, because the indicators in many countries cannot be fully measured. So here again, there is a role for citizens generated data, for remote sensing, to close those data gaps. Earth observation has a big role here. Of course, the traditional way data is being collected in statistical offices is still very important and relevant, and more money needs to also go into that. That's clear. If you look at SDG indicators and what citizens already contribute, so I talked about iNaturalist, eBoard, and those four. So it's already used a lot, citizens' data, for reporting on SDG 15 indicators, especially with respect to reporting on the red list species. Where are the rare species? Where are the species under threat? There's a lot of data being collected there. Also, OpenStreetMap, as we know, is an extremely successful global project with lots and lots of contributions being used also for SDG-related reporting, such as accessibility, which was one of the indicators. This is now one example where Ghana took the initiative, where citizen science is for the first time going into official SDG reporting of indicator 14.1.1b, which is floating plastic in the oceans, where proxy is how much plastic gets flooded along the beaches. And this is the way the methodology works. There has been activities of volunteers in Ghana collecting beach litter, and we were involved, actually, Dilek Freisel, in helping them to make this and formalize this, that it can really be used as a proxy for official SDG reporting. So it's the first official data stream coming into SDG reporting, spearheaded by Ghana. This is how it works. These were these traditional beach cleanups, and then there is a methodology developed how you can then measure the size of these pieces of plastic, the amount, and based on the amount arriving along the beach, you make some very rough estimates of beach litter, but also then the one which is the indicator floating plastic in the ocean. You need some proxies for that, but some data and sometimes citizens' data is better than nothing, because nothing is sometimes what there is. So yeah, indeed, Ghana did really go ahead with this marine plastic proxy indicator and has made big headlines. We also got the GEO Award, Group on Earth Observation Award for this work, actually. What are the challenges of citizen science? So there are lots of challenges out there. Big criticisms, data quality, but there are now ways around also with AI where you can do image recognition of pictures of such things to check the quality being provided by citizens. So all those data which is related to images, and there are a lot of that. But then also engagement motivation is an issue. The data sharing, there is sometimes no protocol for it, and a lot of small initiatives don't know how to make data fair. Big topic also in Open Earth Monitor, fair data. And of course, there are big digital opportunities as well now with AI, and it's not used to the full potential and full extent. There is still a big digital divide between developed countries and poor countries, and many times also in poor countries, citizens have other problems to deal with in their daily life than going out collecting data for free. So the free data collection in developing countries doesn't work. So you need to pay something. That's more or less what it is, boils down to. But there's also a contribution, and this relates to the catastrophic risk, that citizens can really play a role in the transformational change process. And there's very interesting work actually by Ilona Otto on social tipping points. So at what point does a society with opinions and views, worldviews, tip? And there's hope. So you need sometimes a very small proportion of people pushing, which can tip the whole society to something new and evolving. And again, educated citizens, in case governments take science seriously, can play a serious role there, I think. Just to come back to some tools we have developed, as you know, data collection tools on the ground where you can also put statistical samples. So you can tell people where you go, where you need data. We did that, I think it was the first app which had this kind of points to go. Many others are so-called opportunistic data collection tools where you just go out and collect anything. But if you put points, you have so much more control, and we started with some payment system as well, just to understand, can we get better data? Can we get more data? Can we control the data more if we make some small micro payments? Of course, this is also ethically debated if it's exploitation or not. In Europe, it's probably not, but in other countries, it might be. So it's something which is not so easy, but what you get for sure is data. That's the advantage. And you can also then near real time, kind of, we did some tests with Lucas, do the labels of the citizens match what the picture tells, and you can use now AI for that. So you can do a lot of automatic tests for that. I'm just watching the time. I still have a bit of time, then we have 10 questions. But what you can also do is you can check the quality. So as you know, we have an app which does biomass, tree biomass. So it's led by Milutin and the Austrian project, where we use augmented reality to measure the breast height. So following some foresters protocol, but also the height. And, if it's not accurate as it is here, you should go to the highest points. This is not accurately measured. You can see it, you can detect it, you get the pictures, and you can quickly say, is this good quality or not good quality? And here it would be done a bit better. And you can use, for example, PicturePile, which is also an app we decided to tell people quickly, you know, swipe it, what's the quality of this, what you see here. And again, you can combine this very nicely nowadays with AI, and AI indeed combined with citizen science provides new potential, new opportunities. It also can give people some initial trigger. You know, the AI is telling you this. Is it really true? Can you do better than AI? So there are some challenges now for citizens, some gamification element, which can help to trigger also more interest for citizens to participate. But challenges indeed are engagement. So engagement is absolutely critical. There needs to be some fun element. There needs to be something. We also employed in Nigeria a token system where people could report on functioning water pumps in Nigeria. And when they actually reported on that, which is really critical and important, you know, do these water pumps still work, or are they broken? Do they need to be fixed? We use token system, and this is quite interesting because it's a kind of monetary system in their own ways, which they can use these tokens to pay for in local shops. So it doesn't have to be PayPal-based euros or other currencies. It can also be tokens, and that is something quite interesting, which they have been using. Then what is, of course, always important is retention rates. So many times, you know, people participate, they get excited for 2 or 3 weeks, and then it drops off. So continuous contribution is really a big challenge for a lot of citizen science projects. And what is always being done also in iNaturalist and so forth is the gamification, leaderboards and so forth. But coming back to some other work we've been doing with citizen science, but also with experts. So I want to really say we are not tackling everything only with citizens, because the quality is in some cases, especially when you do land cover validation, is not good enough, or you need to really train them up a lot that you really get high quality data. So what matters there when we do this validation, we're also doing some validation now for DeepMind. They are really getting involved in forest monitoring, validating maps, we validated World Serial. We are involved also with OpenGeoHub in Global Pasture Watch. These are individual points we have been collecting and validating using very high resolution. This is actually not a map. These are 150,000 points we provided training data with for Copernicus Global Land, and we continue this in a new project currently running called LCFM, which is continuation of Copernicus Land monitoring, where we collect the training data, and there we really have a trained up team which is very, very good, trained over the last 10 years, really being able to look very closely at these images, also understanding sometimes what is in the field, what is in the ground, what are the patterns. So we are using GeoWiki also for expert-based validation. Thank you. And we don't only use very high resolution Google images or Bing maps or Esri maps or some other background layers. We also use NDVI profiles. We also use Sentinel Hub, actually something which also Gregor has done quite nicely, makes Sentinel data quite nicely accessible through some payments. Of course, it's a company, but Now Planet. But you can nicely see when there is plowing events, which is really important to understand crops and so forth. So we're using all these tools, including on-the-ground pictures, which is really important to make those decisions. Because I only have 2 minutes left, I will move now through this very quickly and come to the last 2 slides. So these are 2 new tools we're developing. It is machine learning AI ready training data collection tool. So a new GeoWiki, which is dealing with segments. So you have to actually classify in a square of, we use around 1 kilometer, 1.2 kilometers, 1 square, very few segments, but you need to be very accurate, and you get the segments already out of some pre-classifier. Then you label the segments. You don't need to label many, but based on that, it is really valuable, and you can then generate new, quite high quality maps with these labeled segments. So this is where we are going to, because then it becomes deep learning ready, and it needs segment labels. And this is kind of the workflow we use. you get some initial tentative segments, then you annotate these segments, and then you get some initial quick AI-based results, and you can loop this through. So there is an active learning element embedded in this as well. This is just latest developments now of GeoWiki 2. More difficult for citizens, but very, very important for experts. And with that, thank you very much.
Okay, we have time for questions. Johannes?
Yeah, thanks, Steffen. Super cool presentation. I was one of the in the clock, you know, this catastrophic clock. There was misinformation, and I find this also being one of the most severe threats. How do you think citizen science, citizens that lose on a broad mass trust in information and follow misinformation, how do you see a role of citizens, you know, collecting data for citizens to in that respect?
I think it's a very good point. I haven't thought about this really, how to operationalize citizen science in this aspect, but I think there could be a role indeed. So I fully agree with you. All the big issues we are having currently, a lot of Europeans, including people here in this country, in Italy, voting for the, so let's, you know, name it, voting for the right, is related to misinformation and partial information. So many times it's not completely wrong, it's partially true, but it's influencing people drastically on their political decisions. And the right has been extremely successful doing this, potentially also with some, there is some hypothesis that Russia has been, to some degree, even understandably involved in that process, that people get really strongly influenced voting for the right because of misinformation and because of partial information being manipulated. And I do indeed see some potential role, but we would need to think about how this could be designed, that maybe, you know, spotting misinformation, having some kind of citizen science activity on spotting misinformation and tagging misinformation somehow could be extremely interesting. Maybe something we can discuss further. But
my hypothesis is just that citizens trust other citizens more in the future than media and politics. So maybe information that comes directly from other citizens is for them more trustworthy than. I mean, it's tricky, but I believe.
Yeah, true. That's a good point. Always the same peers are more believed than somebody telling them. Even scientists are not trusted many times anymore nowadays. Okay, great.
It's a very striking also this chart you show with the TikTok, the information gathered in TikTok. And when I first saw TikTok, I was thinking this is the beginning of the end. I mean, this is like a dopamine feeding short videos, people going like, it's just incredible. But you know, remember that figure, please. It's incredible, the ratio of basically trash in comparison to something useful. And we need to reach young people, generations, you know, teenagers now, younger. We need to reach them, and we need to make the citizen science that they realize that they can be superheroes with it, you know, that they can impact, they can do stuff, they can contribute. And is it a gamification? I don't mind if they do a game, you know, whatever helps get people to take that phone and not, you know, become obsessed with some TikTok, but to see it as a scientific tool, because the phone is a scientific tool. It's a computer now, and it has a LiDAR in it, and I don't know. You can become a scientist, you know. So we need to turn these young people to realize that this is I have a scientific lab on my hand. It's not just some silly, you know, videos and dopamine and things. So yeah, we have to reach young people. I think that's the you do have it for young people, no? Also some projects or programs.
Yeah, actually, YASA has a special program also for schools. So we do quite some training, and there is one activity which is about just climate justice, and also there is, you know, younger generation, there is a group of a younger generation, they really, there is this concept of climate anxiety. It's around, and there are some YASA people, Thomas Schinko is one of them, they're going into the schools, educating, so specifically on education, but there is also some citizen science components in there, yeah. So the Austrian Citizen Science Network is extremely active and strong, also going into the schools.
Okay. Okay, thank you. We move to the next speaker. Thank you so much.